Hello there. In this video, we're going to go through another Q tutorial where what I want to talk about today is having the ability to write your own custom service discipline. In a previous video, we talked about first in, first out, FIFO, and last in, first out, FIFO, and then the service in random order, or SIRO. But in Q, you can define your own custom service discipline. And so I want to show you a simple example from the documentation. But the thing I really want to emphasize is that this is where you get a lot of freedom to write your own for the particular business problem that you're trying to solve. So we'll start off by writing a Python function. And here the example in the documentation is SIRO proportional. And we'll get into, well, we'll add some arguments in a moment. But let's just describe what this thing is supposed to be. Service in random order is the first part, but proportional, meaning follows a probability distribution where the probabilities are proportional to the arrival order. You could call it other things. I'm not exactly sure why the documentation chose this name, if it's already a standard term or if it's just what they decided. For what we need out of this function with Q, it needs to have some criterion. One is it needs to return an individual. Actually, why don't I just put this as part of the types? So in order to do that, let's import Q, and I think it is available at the top level of the package, Q.individual. We need to return an individual. We need to return one of those things that we keep talking about, like as customers or whatever. Q supports another thing called customer class, but this is really what the actual units of flow are called in terms of data structures. They're called individuals. Oops. So, there's some things that any service discipline in Q needs to take as arguments. There's two things, actually. One is the collection of individuals, which, if I remember right, this is a list of Q.individual. And we'll break this into another line. The other thing that it needs to take is T, which is basically the time. So individuals are the candidates for service. They are the ones that are waiting. And the T is the system time. Now, you don't really get to control directly what these are. Indirectly, there are some things you could do, but directly speaking, these are passed in according to the rules inside of the Q package. So all you need to do now is implement your logic here for whatever this is. We're going to keep going with this SIRO proportional idea. So the first thing we'll do is grab the length of the individuals. And then we're going to use one of the old tricks of how many combinations of pairs are there, of saying there's something that's kind of comparative or ordinal in this specific case of the order that the individuals arrived. How many such comparisons can you make between the n individuals? And we're going to use that as a normalization for a probability. So denominator, the bottom of a fraction here, it's just this classic rule that I'm sure some of you learned in introductory calculus probably. N plus 1, n times n plus 1 divided by 2. Actually, I don't think we need those brackets anyway. Okay. And then we can calculate some probabilities. I guess we could break it up into numerators. Yeah, let's do it into numerators. Why not? So we have a collection of numerators that all share the same denominator. We've got n minus I for I in range of the number of individuals. So each of them gets a weight that is proportional to their position in the order that they were given. So then we'll say that the probs, or probabilities, is just each numerator divided by our denominator for numerator in numerators. The documentation does this in one step, but I don't think in this case it's bad to be explicit about what we're doing. And then finally, let's return q.random, and they've got choice, which if I remember right, this is actually just wrapped around the NumPy choice function, so you could use that as well. But it actually doesn't matter. You don't have to use random.choice here at all. All that you need to eventually do is return some choice of individual. Okay, so this is the really important part. You can do this in whatever way you like, given the individuals that are there and the time. And I think I also showed in a previous video, you can access like the global state of the system, or even, I didn't show you, but you can access things that are happening anywhere else in the system locally in terms of like what are the contents of the queues elsewhere, if that was of relevance, or what's happening in other services, or what's happening in this service. You get a lot of access through individuals. So really this might better be generalized to something where we talk about like state, but state and time. But directly it gives you the list of individuals and you decide which individual gets service next. And our kind of contract with Q is that we take those values in and we return a target individual. Okay, so let's throw this into just a toy example simulation. We're not going to put too much thought into the details of the network design here. Let's just go create network and pick our kind of, oh, we're not going to do it from a dictionary, although at some point I should show that. Let's grab some arrival distributions, or maybe we'll just grab one, q.dists, and let's go with a gamma with parameters 1, 2. And then similarly for service distributions, you still have to define all these same things. And the number of servers, let's say that there are 3 servers. And finally, just like when we supplied service disciplines in an earlier video, it's the same thing. It uses the same interface to pass in the built-in ones or pass in your own custom one. And so I can pass in our zero proportional here as just a function. And that should be our network. And let's also set up to actually do a simulation. So we'll go q.simulation, pass in our network class, and then, I don't know, just for the sake of showing something, we will get all records. And we have to actually run the simulation. Simulate until max time, let's go with. And let's say we run for 1,000 units of time. Okay, so it says network is not defined because you do still need to spell words correctly. All right, let's go custom service discipline and see if we've got any bugs or errors to fix out here. No, it didn't. So what should probably be more fleshed out in this example, but I'm not doing it in this video, is to go through and show something about the records. Because while the records won't list what the service discipline was, it should always be consistent with whatever the service discipline is that you coded in, right? So hopefully that, and I think this is actually a really important one, by the way, because this is one of the things that, say you're providing simulation services to some clients, that clients often like to change this piece of simulations, because how they choose what to work on next is usually one of the things that your clients have some control over. And so they like to change it up and say, well, what if we tried this way? What if we tried this other way? Whereas things like demand, they have maybe some indirect influence through things like marketing, but it's very difficult to control demand. So this is something that they tend to have more control over. They like to check out different scenarios of how we select what units of work are completed next. Hopefully that's useful in your endeavors to write up some useful simulations for yourself or for your organization. And with that, I'll catch you in the next video. Have a great day.